Hi, we're talking about the Techno Da Vinci and CO2 Dragster project. We're machining one right now. Right now we're running off my laptop. I have the machine code in there running. But originally, about 4 years ago, somebody came in our classroom and wanted this card to be made right here. And we didn't know what to do with it, and they gave us some Mastercam code, and I asked him how he was going to hold it, and he was kind of dumbfounded. So we didn't know that these machines existed in the county and had fixturing, so we made our own fixture. We pre-machined these pockets that hold the wheels. We drilled the holes in 4-axis. This is very thin, so it's been manhandled many times, but we designed this fixture that would rotate on the 4th axis, so it would hold it like this, and we machine one side and then machine the other. So we thought we'd be able to use it again, but I guess they don't use that design anymore. They still use the same balsa wood shapes with the pre-machined CO2 cartridge hole, but I guess they were meant to be done on these fixtures here. We did a redesign of the holding area. I'll show that later, because we were kind of unhappy with how it rotates and how it held the part. But I really wanted to talk about setup and proving out your program. So we run this in Mastercam. Go back in the room here. As we're a Mastercam University school, we teach Mastercam education here. We also have some other products here. We have a Master 3D gauge arm that runs off of Mastercam and Verisurf. We've done some reverse engineering with this. Very handy tool. And over here we have this is a tutorial by a fellow who runs a website called CUDA Country. You pull this down, and they would design the project, and this would be the Mastercam section of how to run this and how to set it up. So this came into us, and it was not programmed. So the boundary was set on this side. So you have to set a couple of boundaries, one over here, and I actually made another one here, because the tutorial is pretty good, but it didn't have everything we needed. So the blue lines are the tool path, and we have this set that it only goes down about this far. We're not cutting all the way. So also another issue is some people cannot recognize that this, if you don't have a boundary here of some sort, or you pick the back as a check box, it's going to try to go right through the shaft that holds this. So you should be able to recognize when the code does not look correct. The yellow lines are rapid moves, and the blue lines are feed moves. And the red, I don't know if you can pick up the red boundary, is the stock. It's not the actual stock, and it probably should be a different stock design to give you much better analysis, but right now we're just following the tutorial. So this is pretty much the stock boundary right there. So if I fit this and then go into my simulator, I get an idea of how this is going to look right now. So this would be half of the car, and we added some dimple holes in here with the end mill. And right now we're not set up for drilling, so this would be where we have to hand drill those holes out right now. So this is half the car right now, half the car. We had to set a boundary here, and they're going to have to hand rework this section, and that shouldn't be too hard. You have to hand rework the front anyway, because you need attachment on the front, and that's why you have the front boundary, because the only real support is the shaft that goes in the end, and we need some support on this end. Okay, so we're running the Mastercam program. Let's shut some of these tool paths off, on, off. I'm going to go to the stock setup and change it. Actually, I'm not going to display it at all. This is your solid model. I'm going to do a fit. So this is our solid model. So that's our X coordinate is the back half of this. This is X direction. The Y coordinate is the center line of the CO2 cartridge hole. And in this tutorial, you set your Z coordinate to be, 34 millimeters above the center line of the hole. Important information, because when it comes to setup time, you need to know that. Alright, we've got a tool path. We did a hybrid tool path, and we added a couple of drill points right here and here. So right now, this is the tool path. Yellow lines being rapid and blue lines being cut moves. So this is the simple simulation right now. We can watch the tool. Let me zoom up on this. On the play button, we can watch how it goes along. We can slow it down if we want. So imagine this 6mm ball end mill. It's doing those cuts we're seeing right now on the DaVinci. And if you wanted finer increments, you would need to close up a lot of this, the settings that are built into Mastercam. So you have a lot of settings to play with, like step overs. If you press on this step over, it would be how far the spacing is here. Tool containment is the center, transitions, steep shell. These are all little settings, like how far up do you want the tool to go. Arc filter, this is all settings to make it finer and finer increments, which also it adds to run time, but it will make a much smoother part. But it generates a lot of code. All of these lines are very, very little tiny short lines bunched together to make curves. If you can see them right now, they're actually little chords, I think. But to the naked eye, they look perfectly smooth. Little sanding and you're there. Okay, so we followed that tutorial. We go back out. Machine run. Still moving along, so it's still moving along. We actually made some adjustments. We actually moved the spindle motor up to gain as much clearance as we can. Because the deeper we go, the tighter that gets to that frame right there. You notice the frame coming very, very close to the fixture right there. Yeah, on this side, you really have to set the limiting factor of how deep it goes. A good way to tell is the Z direction. We limited it to 37 millimeters, and we're at 31 right now. So we're really running close here. So you have to be careful with them, the knobs in the back, which way they're oriented. Make sure you have no screws hanging up above in that rear area. The front area is not going to be an issue. You're really working close. If you hang the tool out farther, that'll also gain you some more space, but you have to be able to get up high enough to start. So you have limitations in both directions, whether how far down you can go without machine components hitting, or how far up you can go to have a start point. Okay. Right now we're at 34 millimeters, and our bottom number is 37. 3 millimeters, and inches would be 40, about an eighth of, not quite an inch of it, about 1 point. So when we get down to this end, we are just about rubbing. So I believe in this case we're going to have an issue. I think we're going to have to extend this deluxe. We did move the motor. At this point, I think we're going to have to bail out this one. So there's an issue that people can have. Now it's going to come back down. And it's going to go to 37 millimeters. Which is it's probably a hair width away from that. And that's our lowest cut right there. So that tells me we need to extend that tool. I think we got very lucky on that one. Good. Right. 37 millimeters. Which also means we're near the end of the program. It works its way down from the top to the bottom. Let's do in the other direction. Start with 34. I know that one clears. For 34 had no problem. So obviously you got to also watch out where you put that rotating knob at the end. If that was pointing up in the wrong direction, that actually may be your highest point. So we'd have some interference there. Come up, come back down. Oh yeah. I think we lucked out on that one. And 37 on the front side. And so there should be two little dimples and we're done with it. So I'm going to go over, as soon as this cast is empty, settings. You have to do X, Y, and Z configuration settings.